Welcome to the online training, module number 4, lesson 4. Lesson 4 will look at propensity score matching technique. And this lesson will cover an introduction to propensity score matching technique, then look at how to apply PSM or propensity score matching technique, then what is needed to conduct propensity score matching technique, and we'll end the lesson by looking at advantages and disadvantages of propensity score matching. Now, introduction, let's look at what we mean by matching. So matching refers to comparison of elements of the treatment group and control group based on similar observable characteristics. And these characteristics could be age or education, religion, occupation, worth, attitude to risk, or any other characteristic of interest. So matching methods rely on observed characteristics to construct comparison groups. So the key here is observed characteristics. In other words, what is not observed is not considered here. Types of matching techniques that are used in practice include judgmental matching, matched comparisons, or sequential allocation, and others that we saw in module 3 on quasi-experimental techniques or designs. So under perfect matching, it means each individual in the treatment group to be matched with an individual in the comparison group who is identical on all relevant observable characteristics. So finding a good match for each program participant involves estimating as closely as possible the variables or determinants that explain individuals' decision to enroll in the program. However, this kind of matching is usually possible or easy when the observable characteristics are few. However, if the list of these observable characteristics is very large, then it becomes challenging to match directly. This is where propensity score matching technique comes in conditions where the number of observable characteristics is very large, such that it will be difficult to match directly the treatment group individuals and the individuals in the comparison group. So what is propensity score matching? Under propensity score matching technique, an individual is not matched on every observable characteristic, but on their propensity score. So a propensity score basically refers to the predicted likelihood that an individual will participate in the program given their observable characteristics. So under this technique, propensity scores for each individual is computed, both for the treatment group and for the control group. And then those scores, propensity scores, are then matched. So propensity score matching technique matches treatment individuals with similar comparison individuals and subsequently calculates the average difference in the indicators of interest. So the PSM ensures that the average characteristics of the treatment and comparison groups are similar so that we can get unbiased impact estimates. So in other words, propensity score matching helps evaluators to compare individuals from the treatment group that are similar in characteristics with the individuals in the control group. Those individuals that do not have similar characteristics are left out, only those that have similarities, so that the estimate of impact through comparison between the two groups must be done based on individuals that are similar, so that any difference between them can then be attributed to the program. How to apply propensity score matching technique? Calculation of the propensity scores, which is the probability of X based on the observable covariate X that jointly affect participation and the outcome of interest. So propensity scores is nothing but probabilities of individuals participating or not participating in the program. So those have to be computed. Now, propensity score matching technique involves 5 steps. Number 1 is to ensure a representativeness of eligible participants and non-participants have to be representative. In other words, baseline data are preferred for this, for calculating propensity scores, but sometimes endline data can also be used. The matching variables must be variables that are unaffected by the intervention. So the matching variable must not be affected by the intervention, but we want to determine the probability of individuals participating or not participating based on some characteristics that do not affect program intervention. Number 2 is estimation of propensity scores. So how is this done? First, by pooling of samples of participants and participants, then estimate participation D. Then construct propensity scores using the participation equation, which can be either a logit model or probit regression model, in which program participation is equal to 1 and not in program, that is an individual who is in the program is assigned 1, or participation is assigned 1 and not participation, not in the program, is assigned a 0. So this is a logit regression model. The characteristics deemed to affect participation should be well considered and as exhaustive as possible, but should exclude characteristics that may have been affected by the intervention. Hence, it is best to use baseline data to estimate propensity scores. So the participation equation just looks at the probability of one participating in the program or not. After the participation equation is estimated, the predicted values propensity scores of T, which is participation, from the participation equation can be derived. So every sample participant and non-participant will have an estimated propensity score given as the probability of X, where T is participation for the participant, which must be equal to estimated probability of X. Note that the participation equation is not a determinants model. It's not necessarily focusing on factors that determine participation, which is related to outcome. It is just looking at probability of participation, which is considered as propensity score. In that regard, the T statistics and the adjusted R-square are not very informative and may be misleading. For this stage of propensity score matching, causality is not of interest as the correlation of X with T. So here we are just looking at computation of propensity scores, which are done from the participation model. How is bias reduced in propensity score matching program or method? First, if possible, the same survey instrument or source of data should be used for participants and non-participants. Second, a representative sample survey of eligible non-participants and participants can greatly improve the precision of the propensity scores. So if two samples come from different surveys, then evaluators must be sure that the two should be highly comparable surveys. 3, participants and non-participants should be facing same economic incentives. And usually evaluators do this by considering comparison groups from the same geographical area, so that within the same geographical area, participants, whether in the program or in the control group, will basically share certain characteristics, certain economic conditions. Step number 3 in propensity score matching method estimation is determining the region of common support. This is the region where the distributions of propensity scores for the treatment group and the comparison group overlap. So that region where the two overlap is known as the region of common support. So observations in the comparison group with propensity scores lower than the lowest observed value in the treatment group are discarded. Similarly, observations in the treatment group with propensity scores higher than the highest observed value in the comparison group are also discarded. Why? Because those fall outside the region of common support or outside the overlapping space. So what remains is known as the region of common support. Step number 4 is checking for balance or balancing test, where the characteristics of the treatment and comparison groups are compared to test for balance. So note that the two groups may not be observationally similar if misspecification exists in the participation equation. 2, balancing implies that the distributions of the treatment group and the comparison group must be similar, which can be represented as formally to check if the estimated probability of participation is equal to estimated probability of non-participation. Probability of participation must be equal to probability of non-participation, or a participant in the control group. That means they are similar. Step number 5, matching participants to non-participants using matching algorithms or techniques. So each member of the treatment group is matched to one or more members of the comparison group. And the criteria for assigning participants to non-participants based on propensity scores. So this assignment or comparison is, or matching, is based on the propensity scores. And there are different techniques. For example, nearest neighbor matching technique is one of the commonly used techniques for matching individuals in the treatment group and those in the control group. So under nearest neighbor matching technique, each treatment unit is matched to the comparison unit with the closest propensity score, or choose any nearest neighbors and do matching. Usually n is taken to be 5 is used. That is the average of the closest 5 neighbors in the comparison group will be compared to the treatment unit. Another technique is caliper or radius matching. So basically this technique tries to address a weakness of the nearest neighbor matching technique. So one problem with the nearest neighbor matching is that the difference in propensity scores for a participant and its closest non-participant neighbor may still be very high. So they may not be very close, in other words. So the result is poor matches and can be avoided by imposing a threshold or tolerance on the maximum propensity score distance, which is called as a caliper. So instead of just comparing nearest neighbors whose distance may not be very close to the treatment group unit, the caliper method imposes a limitation, a threshold of the propensity scores distance. So caliper matching involves matching with replacement only among propensity scores within a certain range. However, a higher number of dropped non-participant is very likely, which can potentially increase the chance of sampling bias. Another technique is stratification or interval matching. This procedure partitions the common support into different strata or intervals and calculates the program's impact within each interval or stratum. So within each interval, the program effect is the mean difference in outcomes between treated and control observations. A weighted average of this interval impact estimates yields the overall program impact, taking the share of participants in each interval as their weights. So now this matching computation is done first within the strata, and then the average of all the stratas is taken to represent the program impact. Step number 6 is estimation of program effects and interpolate results. This can be done using either single or double difference. As I indicated earlier, that propensity score matching can also be used along with difference in difference method, which is can be done either a single difference or double difference, that is at a single time after program intervention, or the before and after assessment, that is using baseline data and at the end of the program implementation. So how is estimation of effects done? First, calculating the difference between the indicator of the treatment individual and the average value for the matched comparison individuals. Second is averaging out all these differences. So note that in practice, these calculations do not need to be done manually, as statistical packages like Stata, SAS, or ARA are available to conduct this analysis. Then what is needed to conduct propensity score matching? Propensity score matching requires data from both treatment group and potential comparison group. Number one. Number two, both samples must be larger than sample size calculated, since some observations, especially those outside the region of the common support, are discarded. So if a sample is small and some of the observations are discarded, the sample will become even smaller and smaller, which can present some challenges for the analysis. So the sample should be larger than the sample size computed to accommodate those that will be discarded, so that you still are remaining with a good sample size for the analysis. So generally, oversampling must be greater for the potential comparison group than for the treatment group. In addition, propensity score matching can be conducted using data from surveys or administrative records or any other sources. And the data for the treatment and comparison groups may come from different data sets, provided that they contain data on same variables. In other words, they must be defined in the same way. Number two, the data were collected using the same time frame. And this is very important requirement, especially for seasonal variables. That is, variables that are sensitive to the different seasons, such as weight for age, because they may take different values across the season. In other words, they may change across the seasons or over time. So it's very important to take that into consideration. Now, what are the advantages of propensity score matching technique? One, it is always feasible if data are available. And two, it can be done after an intervention has finished, even in the absence of baseline data. However, the main drawback or disadvantage is that propensity score matching technique relies on matching individuals on the basis of observable characteristics linked to the predicted likelihood of participation. Now, what if there are unobservable characteristics? If there are any unobserved characteristics that affect participation and which change over time, the estimates will be biased, and that will affect the observed results. So in circumstances where you have unobserved characteristics, some other factors that can affect participation into the program, then propensity score matching may generate biased estimates of the observed results. And finally, a practical limitation of propensity score matching is the need for the assistance of a statistician to compute these propensity scores and the entire propensity matching technique processes. Thank you for your attention.